x into root of 1 minus x minus root x into square root of 1 minus x square equal to dash. 4 options are given. Here actually one simple formula is there. Sin inverse x minus sin inverse y equal to sin inverse of x into square root of 1 minus y square minus square root of 1 minus x square into y. It is small formula. Okay. Here minus is there. That's why I am comparing the given expression or value with this sin inverse of something. Okay. X is there. Next, instead of root of 1 minus x, there is root of 1 minus y square. So squaring on both sides, it is 1 minus x equal to 1 minus y square. So therefore 1 cancel, minus cancel, y square is equal to x, means y equal to root x. So therefore here instead of y we can write sin inverse of, means question is equal to sin inverse x minus this one. Sin inverse of y means sin inverse of y means what? Root x. This is the answer. So it is in second option. Once again you can verify sin inverse of x minus sin inverse of y equal to sin inverse of x into root of 1 minus y square minus root of 1 minus x square into y. So by using this sin inverse of x means x into square root of 1 minus y square. Here y, it is y square means x minus root of 1 minus x square into root x. So therefore this is the same question. Therefore thus it is second option is right. Tan of pi by 4 plus 1 by 2 into cos inverse of a by b plus tan of pi by 4 minus 1 by 2 into cos inverse of a by b. Here about a comma b, or there are no conditions for a comma b. That's why for our convenient I am taking a equal to b and a equal to 1 and b equal to 2. This is the shortcut. Why? Because cos inverse of a equal to 1 by 2. Cos inverse of 1 by 2 equal to 60 degrees. Then 60 degrees divided by 2, 30 degrees. So we can calculate very easily. That's why I took the simple numbers a equal to 1 and b equal to 2. As you wish, you can take any numbers, any values instead of a comma b. So the question is equal to tan of 45 degrees plus it is 60 degrees. It is 60 degrees. A equal to 1, b equal to 2. 1 by 2, 60 degrees. 60 by 2, 30. So it is 30 degrees plus next tan of 45 degrees minus 30 degrees. So that is equal to, it is nothing but tan of 75 degrees plus tan of 15 degrees. So therefore rough work, tan of 75 degrees equal to tan of it is 45 degrees plus 30 degrees. So that is equal to tan of a plus b formula. Tan a plus tan b means 1 by root 3 divided by 1 minus 1 by root 3. So this is nothing but root 3 plus 1 divided by root 3 minus 1. So rationalizing the denominator, then we shall obtain root 3 plus 1 divided by root 3 plus 1. So that is equal to a plus b into a minus b, means a plus b whole square. So 3 plus 1 plus 2 root 3 divided by 3 minus 1, 2. So that is equal to, it is 4 plus 2 root 3 divided by 2. So that is equal to 2 plus root 3. This is tan 75. Of course, this value is standard value. Already we proved in 11th standard. Okay, that is equal to 2 plus root 3 plus similarly 15 means 45 minus 30. So by putting minus and rationalizing denominator like that, we are obtaining 2 minus root 3. Thus root 3 cancel, it remains 4. So which option is giving 4 by putting a equal to 1 and b equal to 2? Fourth option is right. Hence the problem. Next question. The number of solutions of the equation 2 into sin inverse x whole square minus 5 into sin inverse x plus 2 equal to 0 is dash. Here let sin inverse x is equal to small a. Then given equation is 2a square minus 5a plus 2, that is equal to 0. So factorization 2a square minus 4a minus a plus 2, that is equal to 0. So 2a common, a minus 2 minus 1 into a minus 2, that is equal to 0. So a minus 2 into 2a minus 1, that is equal to 0. That implies a equal to 2 or a equal to 1 by 2. So first case, a equal to 2 means a is what? Sin inverse x equal to 2. But it is not possible. Next, so therefore it is sin inverse x is equal to 1 by 2. Sin inverse x equal to 1 by 2. Means since it is what I am telling that simple solution, if sin inverse of x is equal to theta, that by implies x equal to sin theta. It is true for all x belongs to closed interval of minus 1 comma 1 and theta should be belongs to closed interval of minus 2 comma plus 2. Means that in this interval it is bijective. Bijective means 1 1 and onto function. Whenever it is 1 1 function, there exists for this equation only one solution. So therefore x has unique solution. X has unique solution. X has unique solution. Means that sin inverse of x equal to 1 by 2. Means this value if it is belongs to closed interval of minus 1 comma 1, definitely this equation will have the unique solution. Hence only one solution is there. Question is the problem. Tan inverse of 1 by 3 plus tan inverse of 1 by 7 plus tan inverse of 1 by 13 plus so on up to infinite terms is dash. 4 options are given. So first the given expression or value or question is equal to, it is tan inverse of 1 divided by, actually 3 can be splitting as 1 plus 2. 2 means 2 into 1. Later this one can be written as directly 2 minus 1. Later it can be written as tan inverse of 2 minus tan inverse of 1. We can write like that. Okay. Okay. Next plus second one. Similarly, it can be written as tan inverse of 7 means 1 plus 6. 6 means 3 into 2. This can be written as 3 minus 2. 3 minus 2 is 1. Plus it is tan inverse of this can be written as 1 plus 12. 12 means 4 into 3. This one can be written as 4 minus 3, like that, plus and so on, plus and so on, plus and so on, infinity, up to infinity. Okay, so that equal to, it can be written as easily tan inverse of 2 minus tan inverse of 1, means tan inverse of x minus y divided by 1 plus x into y. Once again, tan inverse of x minus y divided by 1 plus xy can be tan inverse of x minus tan inverse of y. So it is a tan inverse of 3 minus tan inverse of 2 plus tan inverse of, this can be 4 minus tan inverse of 3 plus, and so on. You come here. This is the first term. This is the first term. Its expansion is this one. Second term, its expansion is this one. Third term, this is the expansion of third term. So in first term it is starting with 2. In first term it is starting with 2. Therefore, how can we write the nth term? Nth term, tan inverse of n plus 1 minus tan inverse of n plus, and so on up to infinity. Once again, in first term, this is the first term, this is the second term, this is the third term, and so on. In first term 2 is there. In second term 3 is there. Means what? 3 means 2 plus 1. 2 means 1 plus 1. 4 means 3 plus 1. Like that. N, in nth term it will be starting with n plus 1 minus n, something like that. I wrote the same. So that is equal to, it can be written as limit n tends to infinity tan inverse of 2 minus tan inverse of 1. This is about the first term. Next, plus about this tan inverse of 3 minus tan inverse of 2. Next, about the third term, tan inverse of 4 minus tan inverse of 3. This is about the third term, and so on, plus tan inverse of plus tan inverse of nth term, tan inverse of n plus 1, you come here, minus tan inverse of n, full stop. We need that to write and so on, because instead of this infinite concept, I wrote already limit n tends to infinity. Whenever we are writing or taking n tends to infinity, it is enough to write only n terms, like that. Okay. Next, what is its preceding term? Its preceding term will be tan inverse of tan inverse of n minus tan inverse of n minus 1. Tan inverse of n minus 1 plus, like that. Next, what is its preceding term? Tan inverse of n minus 1 minus tan inverse of n minus 2. Like that. Okay. Here 2, tan inverse of 2 cancel. Here 3 will be cancelled. 4 will be here cancelled. Later 1 should not be cancelled. You come here. Next, n will be cancelled. Later n minus 1 will be cancelled here. So it remains only 2 terms, namely, that is equal to limit n tends to infinity. Last term, tan inverse of n plus 1 minus this one. Only it remains 2 terms, tan inverse of 1. So that is equal to tan inverse of infinity. N tends to infinity means infinity plus 1, infinity, tan inverse of infinity, it is pi by 2. minus, this is the constant, it is pi by 4. So 90 minus 45, 45. Pi by 4 is the answer, means second option is right. Next question. Tan inverse of 4 by 7, tan inverse of 4 by 19, 4 by 39, 4 by 67 and so on up to infinity. So, if possible, it is better to find nth term. But the great advantage is in the numerator, one fixed value 4 is there. Okay, then 50% it became easy. 1 minute. Now, let us consider all the denominators 7, 19, 39, 7, 19, 39, 67 and so on like that. Let us verify whether it is AP or in GP. So 19 minus 7, no, 90, 39 minus 9, no, it is not, it is neither AP, it is neither AP nor GP. So therefore, we have to find the differences in such a case. Once again, take the denominators of all terms like that. Okay, verify whether it is AP or GP. If it is neither AP nor GP, then follow this method. Of course, it is the shortcut to find nth term. Okay, 19 minus 7 is 12. Next, 39 minus 19 is 20. Next, 67 minus 39. 39 means 40, 41, 20, 67, 28. 28, just like that. Okay. Next, 20, once again, 20 minus 12, 8. 28 minus 28. Later, we are obtaining the same 8, like that. It is called differences are in AP. Differences are in AP means T1, T2, T3, T4 and so on T5. They are neither in AP nor in GP. In such a case, mostly 90% we are following this method. So find the differences and clearly we see that it is in AP, right? And how can we find nth term? So let it be, this is A1 value and this will be A2 value and this will be A3 value. Okay, so therefore in such a case Tn is equal to A1 plus n minus 1 into A2 plus half into n minus 1 into n minus 2 into A3, just like that. So therefore Tn is equal to A1 means 7 plus n minus 1 into A2 12 plus 1 by 2 into n minus 1 into n minus 2 into A3 8. So therefore it is 2 4 jar. So therefore Tn is equal to 7 plus 12n minus 12 plus 4 into, means it is n square minus 2n minus 3n plus 2 into 4, means it is 4n square minus 12n plus 8, just like that. Next Tn is equal to 4 n square, 12n cancel. Next 7, this is 15 minus 12 plus 3. So therefore already in the numerator 4 is there, that's why we can take 4 common. This will be n square plus 3 by 4, just like that. Okay, so therefore question is equal to, actually this can be written as in terms of sigma Tn. Tn means tan inverse of 4 divided by, for the denominator we can write nth term 4 into n square plus 3 by 4. 3 by 4. Okay. Next, n equal to 1 to n. For infinite terms, we can write simply like that. Summation, it is for plus 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 plus. Next, n tends to infinity and writing nth term. So simply the given question can be expressed as like that. Okay, anyhow 4 cancelled. Then it remains limit n tends to infinity sigma 1 to n tan inverse of 1 divided by, actually it can be written as 1 plus n square minus 1 by 4. We can write like that. Okay. Next, so that is equal to limit n tends to infinity. You can ask me, sir, what is the need of writing like that to obtain tan inverse of x plus y divided by 1 minus xy or x minus y divided by 1 plus xy formula. That's why I am trying to obtain that formula. So okay, so this is denominator 1 plus actually this is n plus 1 by 2 into n minus 1 by 2. We can write like that. Next, in the numerator 1 is there, that's why it can be n plus 1 by 2 minus n minus 1 by 2. Minus into minus plus 1 by 2 1 n in cancel. So there is no loss of generality. Now strictly it is in the form of tan inverse of x minus y. So that is equal to limit n tends to infinity, it is sigma 1 to n. It can be tan inverse of n plus 1 by 2 minus tan inverse of n minus 1 by 2, like that. Already I said tan inverse of x minus y divided by 1 plus xy. 1 plus xy. Tan inverse of x minus y divided by 1 plus x into y equal to tan inverse of x minus y, just like that. Okay. Next, just open the sigma value or open the sigma. It is limit n tends to infinity. So n equal to 1, 2, 3 and so on n. Substitute like that. First n equal to 1. Put n equal to 1. Then it is tan inverse of 3 by 2 minus n equal to 1. 1 by 2. Tan inverse of 1 by 2 over. Next plus. Put n equal to 2. 2 means 2 to the 4. 5 by 2. Tan inverse of 5 by 2 minus tan inverse of n equal to 2. 2 to the 4. 3 by 2. It is 3 by 2. Okay. Plus and so on. Plus and so on. I am writing the nth term. Tan inverse of n plus 1 by 2. 1 by 2 minus tan inverse of n minus 1 by 2, like that. Okay. What is its preceding term? Means put n equal to n minus 1 for obtaining the preceding term. So n minus 1 means n minus 1 by 2. So plus tan inverse of n minus 1 by 2 minus n minus 1. N minus 1 means n minus 3 by 2. So tan inverse of n minus 3 by 2, just like that. Okay. Anyhow, tan inverse of n minus 1 by 2, tan inverse of n minus 1 by 2, later this will be cancelled here like that. Next 3 by 2 value cancelled. Next 5 by 2 will be cancelled here. So ultimately it remains only two terms, namely tan inverse of n plus 1 by 2 minus tan inverse of 1 by 2. So that is equal to, with respect to n, it is the operator. It is the operator. It affected with only this term because it is a constant value with respect to n. Therefore, put n equal to infinity. Infinity plus 1 by 2. Infinity. Tan inverse of infinity. Tan inverse of infinity minus tan inverse of 1 by 2. Okay. This tan inverse of 1 by 2 can be written as in terms of cot inverse 2 by 1 means 2. To how? You come here. Tan inverse of 1 by 2. Tan inverse of 1 by x equal to, simply we can write cot inverse of x if x is positive. Okay, already 2 is positive. Okay, next that is equal to, what about tan inverse of infinity? Tan 90 degrees equal to infinity. So 90 degrees equal to tan inverse of infinity. Tan 90 degrees equal to infinity. 90 degrees equal to tan inverse of infinity. So it is 90 degrees means pi by 2 minus cot inverse of 2. Basically, you come here. Tan inverse of x plus cot inverse of x, that is equal to pi by 2. Then cot inverse of tan inverse of x equal to just pi by 2 minus cot inverse of x. So therefore, compare with this formula, whereas x equal to 2, then simply it is called tan inverse of x means 2. So answer is tan inverse of 2. This is the right answer. Hence the problem. If box of cot inverse x plus box of cos inverse x equal to 0, where x is a non-negative real number means x is greater than or equals to 0. Next box denotes greatest integer function. Then x belongs to this interval or this interval or this interval or fourth option. Okay, 1 minute. First remember one basic point, cot 1 radian is greater than cos 1 radian. Already I said in first year, I mean 11th standard trigonometric ratios, I said sin 1 is 1 greater than sin 1 or sin 1 is greater than 1. That kind of problems already I said in the classroom. Okay, 1 minute. Next, actually cot inverse x range will be 0 to pi, open interval of 0 to pi. At the same time, cos inverse of x belongs to closed interval of 0 to pi. It is open interval of 0 to pi. This one is closed interval of 0 to pi. Okay. Next, what about pi means what? It is 3.14. So then box of cot inverse of x is what? 1 minute. Actually here 0, 1, 2, 3 and 3.14. Cot inverse x lies between this 0 to 3.4 like that. Okay. If cot inverse, for example, cot inverse x lies between 0 to 1 means in this area, then its box value is equal to 0. This is lower bound, this one is upper bound. Similarly, in this area means 1 less than cot inverse x less than 2, then this value is equal to 1. Next, 2 less than cot inverse of x less than 3, then its value is equal to 2. Next, 3 to cot inverse 3 to pi means 3.1, its value is equal to 3. In the same sense, cos inverse x is also like that. So box of cot inverse x is equal to 0 or 1 or 2 comma 3. 4 solutions are there. Similarly for this box of cos inverse of x will be 0, 1, 2, 3 in this interval. But the given question is sum of two boxes will be 0. Therefore, definitely box of cot inverse of x is equal to 0 and box of cos inverse x is also equal to 0. Understand? Otherwise, it should not be equal to 0. Means sum should not be equal to 0 because all are non-negative values. Okay. Now, now it is possibly already I said 0 to cot inverse x. So in this case, cot inverse x will be like that. In this case is equal to 0. In this case also box of cot inverse x is equal to 0. But here cot inverse range cot inverse x it belongs to open interval of pi. That's why I didn't write is equal to here. In general, come here. Box of cot inverse x equal to 0 means if cot inverse x equal to 0, then also its box 0. And if it is lies between 0 to 1, then also it is 0. Okay, 1 minute. Rough work. Cot 0 is what? Cos 0 divided by sin 0. Cos 0, 1. Sin 0, 0. That is equal to infinity. Next, so therefore that implies cot of 0 less than or equal to x less than cot 1. But it is not right because cot theta or cot x function is always decreasing. Means cot x function is decreasing in all four quadrants. That's why we should not write like that. We should write cot 1 less than x less than infinity like that. Okay, did you understand this step? Actually, I am telling that if cot inverse x a less than or equal to cot inverse x less than or equal to b. This is the statement. Now, generally we are writing cot of a less than or equal to x less than or equal to cot b. We are writing like that. But cot is a decreasing function. That's why we change it like that. Not a to b, b to a, just like that. Because cot x is decreasing function. Okay, next. So this is the first statement. Remember, already I said cot 1 is greater than cos 1. 1 minute. Next, about this. So in this equation, 0 less than or equal to cos inverse x is less than 1. Actually, here we are writing cos 0 less than or equal to x less than cos 1. Don't write like that because it is x-axis, y-axis, cos graph. It is minus pi by 2 plus pi by 2. It is 0. So it is decreasing function in first quadrant. Therefore, we are writing cos 0 means here cos 0 less than or equal to cos 0 x less than cos 1, just like that. So that implies cos 1 less than x less than or equal to cos 0, 1. So this is the second statement. But already we did know cot 1 is greater than cos 1. So therefore we have to find the combined solution of three statements. You come here. This is the real line. X line cos 1. Cot 1 greater than cos 1. So suppose it is cos 1. Because cot 1 is greater than cos 1. That's why let us take it is cot 1. And like that 1. So cot 1 to infinity. Cot 1 means this is cot 1 to plus infinity means this is blue area. Next another is cos 1 to 1. Cos 1. Cos 1 means this value to 1. Here is equal is there. That's why we are considering closed interval. So this is black and shaded part. So therefore the combined solution is x belongs to, come here, x belongs to open interval of cot 1 comma 1 closed. So which option is right? Open interval of cot 1 closed 1. So third option is right.